Alright friends, welcome back to the fourth vodcast. We're on problem BB. This problem says, let's get back in here, I'm a little tired. Magnesium metal, Mg0, is added to nitrogen gas, N2, 0. It's really important you put that 0. It really helps you keep track of things. So you got two elements, one's going to have to go up in charge, Mg2 plus, nitrogen is going to go down in charge, N3 minus, charge switchy. Balance it out, 2, 2, 2, 3. So I'm going to put a 2 here, put a 3 here. It's going to change to a 4. Sorry, I'm stupid. That should be a 3, that should be a 2, which means all you have to do is put a 3 here. And 1 there, sorry about that. What is the oxidation number of magnesium before it's 0 and after Mg2 plus? So it's oxidized, which makes it the reducing agent. Solid lithium hydride is added to distilled water. Hydride is H-1. Solid lithium hydride would be LiH, and it's added to distilled water. This is on the cheat sheet. Okay, metal hydrides and water. They're going to form a, I believe it's a basic solution, and it's very similar to putting an alkali metal in water. You're going to form the strong base, and you're actually going to get some explosive hydrogen gas. One of the most dangerous things about putting alkali metals in water is the final solution acidic, basic, or neutral. It's going to be basic, produces OH minus in this case. Metal hydrides would react with water to produce metal hydroxides. So alkali metal hydrides, metal oxides, or plain alkali metals produce basic solutions in water. Very important thing to understand. Benzene is treated with bromine in the presence of a catalyst. All right, this reaction is an organic reaction. I do want you to make a flashcard for it, but it's a really interesting reaction. Benzene has this formula C6H6, and when you react with bromine, that's 0 in this case, you actually get C6H5, and one of the bromines gets ripped off there, and you get hydrobromic acid. But what this really looks like is interesting. Benzene is this funky molecule. It's this big ring. Okay, and it reacts with bromine, diatomic bromine actually. You could draw diatomic bromine out this way. What really happens is one of these hydrogens and that bromine, they react together. Okay? And that's where the HBr comes from. And this bromine actually sneaks in there and replaces it. So we get the benzene ring with a bromine stuck on there, and we get the hydrobromic acid. You know, oftentimes, guys, you might see benzene rings represented this way, where this resonance that happens in the center of the ring can be represented in the form of a circle. So that's what that would look like. Classify the type of organic reaction that happens here. This is, you know, exactly what it looks like. It's called a substitution reaction. Very unlikely you're going to get asked an organic reaction, but that's what happens there. Solid lithium oxide is added to excess water. Okay, we got a metal oxide and lithium oxide. It's solid. Is added to water. Metal oxides react with water to produce basic solutions. In this case, you're going to have a 2 right there. We saw that before. They're probably going to ask you if it's acidic, basic, or neutral. It's basic. Why? Because of the OH. Basic due to presence of hydroxide. F, potassium chlorate. Solid, so it's going to be together. Potassium chlorate is heated, different than burned. It's going to decompose in the presence of a manganese dioxide catalyst. Remember, all a catalyst does is decrease the energy of activation of the reaction to make it happen faster. A catalyst is not part of the reaction. It's regenerated, it helps it happen faster, it takes it on a new path, but you do not have to include it in the reaction. Okay? Well, what are the most common sense things for this to break up into? Oxygen gas would definitely be one of them, and the subsequent chloride would be the other. We're going to have to put a 3 here, 2 here, and a 2 here. This is directly off the cheat sheet, heating chlorides. How many moles of reactant products can be produced from 1 mole of potassium chlorate? Okay, well, 2 moles gives us 5 products. So 1 mole, okay, would give us half of that, 2.5. Let's go back and correct, 2.5 moles of products. This came from that 2 and that there. A very good question. Dilute hydrochloric acid is added to solution of potassium sulfite. Okay, hydrochloric acid, strong acid, going to show it apart in water. It's added to a solution of potassium sulfite, K plus SO3 sulfite 2 minus. Remember that sulfate is SO4 2 minus. Sulfite would be SO3 2 minus. You go down to ite, you lose an O. Okay, connect and cancel. I see my ions. Okay, I'm going to form a soluble K plus Cl, and I'm going to form a weak acid in sulfurous acid. Going to get rid of my spectator ions there. I'm going to get rid of my spectator ions here, and I'm going to balance this bad boy just like that. And what they actually have it doing is this thing breaking up subsequently into H2O and CO2, just like carbonic acid breaks up into, or SO2, into H2O and CO2. Sulfurous acid breaks up into H2O and SO2. So spectator ions, though, were the K plus and the Cl minus. Those are the spectator ions in this case. If you don't remember to do that, that's okay, but it's a nice thing to be able to remember. Solution of sulfuric acid added to a solution of barium hydroxide until the same number of moles of each compound has been added. Fancy way of saying that you're adding the strong base, H plus, SO4, 2 minus, to barium hydroxide, strong base, OH minus. I see ions, so I'm going to connect and cancel. You're going to get a precipitate, BaSO4, and you're going to make liquid water also. So in this case, there is no spectator ion. This stayed together and this stayed together. Is the final solution acidic, basic, or neutral? In this case, the answer is going to be neutral. Okay, you do form H2O, and they also told you that until the same number of moles of each compound has been added. You're adding a strong base to a strong acid, and yields a neutral solution. Again, strong acid plus strong base. Who wins? Nobody wins. Okay, it's going to be neutral. No one was stronger. In that initial case, when the acetic acid was added to the sodium hydroxide, the strong base won. But in this case, strong acids and strong bases lead neutral solutions. A mixture of solid calcium oxide and solid tetraphosphorus DEC oxide is heated. Is the final compound soluble in water? So you're going to make calcium oxide, and you're going to mix this with P4 tetraphosphorus DEC oxide, O10. Okay, you got a metal oxide and a non-metal oxide. It's going to make the subsequent ionic compound. Calcium and O, P's and O's are going to make a phosphate ion. So that's going to be Ca3, PO4, 2. Balancing this reaction can be a little tricky. You're going to have to put a 2 here. And I believe you have to put a 6 here. Is the product soluble in water? No. Okay. It is a alkaline earth metal with a phosphate. All phosphates are insoluble other than those from the alkaline metal. So it's a phosphate not from an alkali metal. Okay, so again, metal oxides and non-metal oxides, you're going to take the metal, you're going to put it in the front, and you're going to take the remaining non-metals, and you're going to think about what polyatomic comes from those. In this case, it's PO4 3 minus. See you guys on the next clip. One more and we're done.